Have you ever wondered why we consider algorithm and data structure one of the most important subjects in the computer science field? Let's consider the following example. Let's assume like you order an online order from your favorite e-commerce, and this e-commerce company is trying to figure out what is the best way to deliver your order in the minimum time possible. Now, let's assume like we have this small 3D map of your town where the red arrow is pointing to your house at point A, and the provider has the e-commerce company has two providers at point B and point C. For sure, we have multiple routes from both B and A to the house B and C to the house A where we can deliver the order. So let's like play an simple animation represents the all different routes from B to A. As we can see, like we have multiple routes with different delivery time and with different like length, but they share some common roads between them. On the other hand, we have also different route from the provider C, also with different delivery time and different length and cost, but still share some roads or some intersection with the routes of the provider B. Now, this suggests the following questions. Which provider should we use to deliver the order? And what route should the provider use to deliver the order? To answer those two questions, we can like ignore the irrelevant information or irrelevant data like the buildings around the roads, the car speed, the road material, and focus only on relevant information like road length, the intersection point, which help us to build this abstract model of the city where each node represents like a road intersection and each edge represents like a road between two intersections. Now, by abstracting like the city map, now we shift our problem into finding the minimum length path between point B and point A on the graph and between the point C and point A on the graph. So if we draw the path, we can quickly figure out like that the best provider to choose in this case is the provider B with the red route between B and A. But what if there is some additional information about the problem, like real life scenario where we have like one direction road when so you cannot like enter from certain entries. So in this case, we need to represent the problem using directional graph when we have an additional information about the direction of the edge. For sure, using directional graph will change the best route to reach to A from both B and C. Now, what if we have an extra information about like there is some works on route B? So this will add some information about the weight or cost of the edge, which for sure will affect the best route to choose and the best provider to choose. As we can see, like graph representation simplify the problem and help us to make a better decision for small town, and it will be for sure way more useful when you have a large city with hundreds of orders a day. Thank you for watching and hopefully see you next time.